Okay, let's continue. So that means input alphabet maybe 0 and 1, maybe AB or maybe PQ. That means here we are going to highlight that what are the input symbols we are going to use, okay, when we are going to design the strings or create the strings. The next one is transition functions. Okay, what is transition? Jitul, you unmute yourself and say what is not about the transition function. What is transition in general times? What is transition?
Sir,
Sir, transition means uh, going from one state to another state.
Okay, changings. That means there are some change. It in transition means in our, yeah, our life also, when we grow, that there are some transitions in our physically, mentally. Okay, that means transitions means when we travel from one state to another, from teenagers to adults, suppose, from adult to old, okay, from baby to teenage. Okay, that means there are some transition. So here, as I told you, you are going to start your journey from, suppose, Ganeshguri. Okay, then your next state is, suppose, Khanapara. That means the bus will stop at Khanapara.
sir, your
Once,
voice is
hello.
sir, voice is breaking, sir.
Is it clear now?
Yes, sir. Yes, sir.
Okay. So that means when we start a journey, suppose it's not like that. Suppose you are sitting somewhere, can you move from this particular position without using any kind of activity? It is not possible. Either you have to get up and move by yourself, or someone else will force you. Then only you will move from one place to another. That means there should be some external force while you uh, move from one place to another. So similarly, when you start your journey from Ganeshguri as a starting state, and your next destination is state, not final, okay? Your next destination is Khanapara. You have to start your journey. You have to start your car. That means here, what is your input? Your input symbol is car, suppose. Okay. When you use your input symbol to execute something, then only you can travel from Ganeshguri to Khanapara. That means the whole procedure should be defined under a single umbrella. That means where there are some current state, and there will be a final state, and from the current state to final state, we need a input. Okay, using the input we can travel from current state to final state. The whole procedure will be highlighted under the transition function. That means under transition function, under transition function, we can say that this is my present state, this is my next state, and to reach from present state to next state, I am using this component as a input. And the next state may or may not be the final state, because in this case Khanapara is not my final state, it is simply the next state. After that, the next state is Sagirut, suppose. After that, Roha, then Nagaon, then Koliabor, then Mission Saili, then Tezpur. And when my next step is Tezpur, Saidur, you cannot hear me. Others, are you able to hear me?
sir, it's okay now.
Okay, okay. Sometimes due to the network, maybe one or for few seconds, maybe some interruption. Okay.
Yes, sir.
So immediately share your problem in chat box. Okay, I'm opening the chat box so that I can get the information immediately. This is called transition functions. That means where we highlight your present state and your next state and the input symbol, using which I can move from my present state to final state or next state, and the next state may be or may not be the final state. So similarly, the fourth tuple is Q naught, that is the starting state. That means from where we are going to start our journey. In this case, Ganesh Guru is my Q naught, and the set of final states. That means the initial state is always one, but in some exceptional cases, the final states may be different. Okay, in some, that's why it is called a set of final states F, where within F there may be one or more than one states which can be considered as a final. Okay, so when we go for the example, it will be more clear. Do you get my point? Is it clear what are these five tuples and where we can use it? Is it clear to everyone?
Yes, sir.
Okay, good. DC, the transition function, because the apart from the transition function, all the other entity simply carry some informations. That these are the information you have to use it. These are the information you will get after you execute something. Okay, that means the input symbol, they simply carry the input symbols. Apart from this, apart from carry the input symbol, they don't have any activities throughout the procedure. Similarly, the states, which simply highlighted, these are the states you have to go through. Q not carry this. This is the final state. Capital F carry that this is the final state or these are the final states. The only execution which happen throughout the procedure under the transition functions, where you have we have a symbol called delta which represents the transition functions, where we give the two inputs. One is called present state Q. Q represent present states. Okay, Q not means initial state, but when you write single Q, it may be Q naught, it may be Q1, it may be Q2, it may be Qn, and n is the final state, suppose. In generalized time, because it is a generalized equation where two input we have to give to the transition function. Take two arguments. We know arguments means the input in the function. Two arguments, and the two arguments are a input symbol, a in present state Q. For every transition, the Q changes. It may be Q naught, it may be Q1, it may be Q2, it may be Q3, dot, dot, dot. It may be Qn minus 1. Because when you reach the final state, you are not going to execute the transition function more. Okay, so that means in transition function, Qn minus 1. And if there are more final state, then the situation is something different. But normally, in transition function, two input you have to give, one in terms of the present state, and next is the input symbol. And what will be the result you will get? And what is the result you will get? The next state. The state that the DFA goes to when it is in state Q and the input symbol A is received. That means once you sit in the car, once the driver start the car and start driving, what will be your result? That means after some time you will reach Khanapara. Similarly, when in a transition function you give your present state and an input symbol and start executing, the result is suppose the next state. That means suppose you have states like, suppose q0, then q1, then q2, where q0 is your initial state, q2 is your final state. Yeah, and input symbol is 0 and 1. So when you give q0 in when you give two arguments to the transition functions like q0 and 0, it will reach to q1. Is it clear to everyone? Good. You are very much smart actually. And to represent the DFA, we have to use the transition graph. That means suppose in DBMS, in a fifth semester itself, you have a DBMS paper where you find a topic called a particular chapter called ER diagram, where you where you use some symbols. Okay, using this symbol, you can highlight that these are the entity, these are the attributes, these are the relations. You can connect these two entities via this particular symbol. So everything can be done, or everything can be explained graphically. So similarly, whatever we are discussing right now, suppose मैंने जो बोला है कि Q एक इनपुट स्टेट होगा और प्रेजेंट स्टेट होगा, उसको उसके साथ एक इनपुट सिंबल भी होगा, दोनों को हम लोग इन ट्रांजिशन फंक्शन में फिट करेंगे, उसके बाद हम लोगों को नया एक स्टेट मिलेगा. तो एवरीथिंग कैन बी एक्सप्लेन graphically. That means it's better, and actually it will be much more easier to understand when we explain the same thing graphically. Okay, that's why we need a transition graph. Okay, in this transition graph we use some symbols, which highlights some specific what I say, highlight some specific informations, like how we can understand that this is the initial state. That means there are some criteria, there should be some indication that if this particular symbol is associated with a particular state, that this state is the initial state. If this particular symbol is associated with a particular state, that means this is the final state. Okay, if this particular symbol is associated between two states in a particular order, we can say that from this state I can move to this. That suppose from, for example, suppose arrow. Based on this arrow, I can say that from we are traveling from left to right. Suppose this arrow is from left to right, then we can say that we are moving from left to right. That means for this we have some symbols, we have to represent the whole scenario graphically so that we can understand it more efficient way, or we can validate the strings we have created based on the particular language by using some input symbols. Yeah, graphs representation of DFA. What we need to represent a DFA using graph, we need the nodes or states, we need some input symbols, we need the arrow marks, because using the arrow itself I can say that I can move from this point to this point. Then we need some additional symbols which highlight that this is the final state. And once we apply all these things to a particular language, to define a language, then this will be this type of what we can say, this type of graphics will appear which represent a DFA, and using this DFA we are going to validate some strings. Okay, we are going to validate some strings. And what are the symbols? That means there are three states, A, B, C. That means under capital Q, what are the states will appear? Capital A, capital B, and capital C. Okay, then in the summation functions, where we have to highlight the input symbols. What are the input symbols here? That is called 0 and 1. That means every time under this arrow or under these symbols, or sorry, near the symbols, we use these input symbols. That means here the input symbol is zeros and 1. That means from A to B, either I use 1 to reach B, or from A to A itself we use 0. That means these are two input symbols. Then for each transition, suppose you want to move from A to B, there is a transition function. If you want to move from B to A, there is a transition function. If you want to move from B to C, there is a transition function. If you want to move from A to A itself in a circular path, there is a transition function. If you want to move from C to A, that means this arrow highlights that from where to where you can travel. Okay, for each and every transition there is a transition function where we give the present state, we give the input symbol, and we give the, or we'll get the next state. Then this particular arrow, when we write as a start, that means from this A state we'll start our journey. And this double, when we get the double circle, okay, these states are considered as a final state. That means in this case, and starting state is always 1. Okay, but final state may be more than 1. And for the, suppose a same state may be the initial state, or and may be the final state. Okay, that means in this particular DFA, this DFA going to highlight accept all strings without 2 consecutive ones. Okay, this is the starting state, and this is A and B is final state, and C is intermediate state. Now what does it mean? Accept all strings without 2 consecutive ones. That means we cannot get 2 ones together. That means 101 is acceptable, but 110 is not acceptable. How we can validate? Suppose from here we start A. Okay, okay, if when we travel from A to B, what input symbol we will get? 1. Okay, 1. Then again if we travel B to C, we will get again 1. That means 2 ones. No, this cannot be happen. Suppose if we travel from A to B, then again B to C, what input symbols will get? 1 and 1. That's why it is called conjugative ones have been seen. That means this transaction is invalid. That means you cannot move from A to B and B to C directly. Either what you have to do, you have to move from A to B, then again you have to do a reverse to B to A, then again you have to go to B, then you can go to C. Then 1, 0, 1, again if we go to 1 C, then again consecutive to 1 is appear. Why we cannot go to C? Because after C there is a no comeback to B or A. That means if we cannot come to a final state from a particular state, we cannot move to that state. যদি আমি শেষৰ ষ্টেটটোলৈ আহিবই নোৱাৰো এটা পাৰ্টিকুলাৰ ষ্টেটৰ পৰা, আমি সেই ষ্টেটটোলৈ নাযামেই, because without reaching the final state, that DFA is incomplete, or it goes to a, this particular string goes to a infinite loop. কাৰণ আমি C পৰা we cannot back from C to B or A. That means we cannot move to the final state. That's why we are not going to move to the C, because to complete a string or to complete a transition or to make a string accepted by a particular DFA, you must reach the final state. If you are not able to reach the final state, that means your string is invalid. It goes to an infinite loop. That's why always remember, only traverse to that stage from where directly or indirectly you can able to reach the final state. Okay, this is something called graphical representation of DFA. That means when we do some examples, you we have to create some strings. We have to make this string accepted by a DFA. There are different criterias are there. But when you got a question of draw a DFA for a particular string or particular language, that means at the end you will get this kind of scenario with maybe more than three sets with multiple states, but at the end you will get a scenario like this where there are some states, where there are some input symbols, there are some intermediate states, there are some final state, there are some arrow marks, and there is a initial states, and using this sequence we have to make a string acceptable. Am I clear to everyone? Okay, good. So I'll continue in the next class. Okay, but you should are you able to assess the notes in ERP? Yes, I'm not able to hear you. Hello, Nikhil. I'm not able to hear you. Okay, yes. So you go through the notes, and in net also you can go through what is transition graph, how do go through some examples and try to understand the things. Okay, then suppose what is transition table. In the next class we go for the transition table and everything. But I feel that if you go through this topic previously, whether you are able to understand or not, at least you are supposed to like, yes, it is familiar to me, I have seen these things earlier. So go through the topic and try to make you familiar, so that when we discuss, it's not like that it is a completely new topic, new concept to you. Go through it, try to understand, and in the class also obviously we are discussing each and every point. But if you go through the topic previously, then it will be at least familiar to you. Okay, okay, I will continue in the next class. Okay, and if you have any query, you go through the topics which we have discussed. Go through the topics, and if you have any query, you can ask me in the next class or in your in WhatsApp group also. Okay, thank you everyone.